Well, hello guys, Mr. G here with another question. This time we're going to be doing question on rate of reaction. This one is question 5 from June 2016, the paper 2. We already answer all the paper 1. We're going to be do the same with paper 2 of the same year. But we're going to start with the rate of reaction and we're going to answer a couple of questions on rate before we finish this question paper. We're going to start, but before that, don't forget to subscribe for the channel so you can get all the notifications and worksheets that I post on regular basis. Now we're going to start with this question. This question states, in a certain amount of nitrogen monoxide react completely in excess oxygen in a closed container of adjustable volume according to the following balance equation. And then you can have the equation of nitrogen monoxide react with oxygen to produce nitrogen dioxide. The graph below shows the volume of nitrogen dioxide formed. So this graph here represents the product that was formed during that chemical reaction. Okay, and now fully describe the change in rate of production of nitrogen dioxide during the 8 minutes as shown in the graph. So what we have to answer here? Okay, looking at the graph, we can see that initially the gradient of the graph is very high, it's very close to the y-axis. What does it mean? It means that the reaction is occurring very fast. So all we have to say first for question 5.1 is that initially the reaction rate is high. However, as the time passes, you can see that the gradients turn out to shift away from the y-axis. Therefore, the reaction rate gradually is going to decrease. And then it's going to decrease eventually up until the reaction is done. Here, at this point, when the line is parallel to the x-axis, it means that the reaction is done. And therefore, the rate is 0. So this happens until the reaction is complete. And guys, this is question 5.1. Quite simple. Let's go to question 5.2. What is represented by the horizontal section of the graph? We already mentioned that represents that the reaction is done. The reaction reached completion. So let's write it down right here. The reaction reached completion. That is that line. Let's go to question 5.3. Calculate the average rate of production of nitrogen dioxide in centimeters per second in the first minute. So calculate the rate of the reaction, guys, in the first minute, the rate at which that volume was produced there. And we're going to do that one right here next to the graph. This is question 5.3. The rate at which the volume is produced for the first minute. So I'm going to write rate is equal to change in volume divided by change in time. Now know the following: change in volume, because they are telling you here that it must be in centimeter cubic per second. So in other words, they're asking you volume per second. So here, change in volume for the first minute. If you go there for the first minute, 1 minute is here, is marked on the graph. So the volume at that point was 15. So then rate is equal to 15. The initial volume was 0 divided by the time. The time was for 1 second. They wanted you in second, no in minute. Is 60 minus 0. And then the rate is equal to 0.25 centimeter cubic per second. This is the answer for the rate that they want you to calculate in that question. Very simple. That is question 5.3. Okay, so let's go to question 5.4. 5.4. If the initial volume of oxygen present in the container is 40 cubic centimeter, calculate the total volume of gas present in the container at completion of the reaction. Okay guys, now here is some stoichiometry. Now for this one we have to analyze a couple of things. They tell us that the initial amount of oxygen was 40 cubic centimeters. So the initial volume of oxygen was equal to 40 centimeter cubic. But I want you to note also that oxygen was in excess. So what does it mean that is in excess? It means that not all the oxygen, not all the 40 cubic centimeters was used up. Now what do we know? From the graph, we know that 35 cubic centimeters of nitrogen dioxide was produced. So this is the volume of nitrogen dioxide produced. Okay, so now to produce this one, let's just write it with another color here. To produce this amount, we need to know how much oxygen was actually needed. Now note the following. In the case of the nitrogen monoxide, it was completely used, guys. It is completely used because this one is in excess. So at the end of the reaction, there is not nitrogen monoxide left inside the container. You only have at the end, you have the product produced, all the nitrogen dioxide produced, and some leftovers from the oxygen. So how do we know this one? First of all, we're going to use the ratio to know how much oxygen was needed to produce this amount of nitrogen dioxide. So we're going to use the ratio of O2 to NO2. Right? So the ratio is going to be 1:2. And I want to know, to produce 35 cubic centimeters of nitrogen dioxide, how much of this one I actually need. And this one, guys, is cross product. You all know that. It's not the first time we answer this one. So when you answer this one is 2x equal to 35. So x is equal to 35 divided by 2, which is equal to 17,5 cubic centimeter. Now, what is this? This is the amount of oxygen needed to produce that amount there. But how much is left? How much is left from oxygen? Well, from oxygen, if we started with 40 and we used up 17,5, we have left 22,5 cubic centimeter. This here is left. It's left behind. Okay, so what is the total amount of gas at the end in the container, which is the question here? Well, the total amount of volume present in the container is going to be the whole volume of the nitrogen dioxide plus the one that is left from the oxygen. In other words, the total volume at the end is going to be equal to 22,5 cubic centimeter. All this is cubic centimeter, guys, plus the 35 centimeter that is produced. So it means we have at the end 57,5 cubic centimeters. Guys, this is the amount of gas left behind in the container at the end of the reaction, which is the addition of 35, the product, plus the leftovers of oxygen. Guys, I hope you understand. This is not that bad. This one is stoichiometric from grade 10 and grade 11. Let's go to question 5.5. Sketch the above graph, not at scale, to value except on the axis. In your answer book, label the graph P. On the same set of axes, sketch the graph that will be obtained if the experiment is repeated using 30 centimeter cubics of oxygen. Label the graph as Q. And now I want you to notice something. Initially, they used 40 centimeter cubic. However, they only needed 17. This is what it was needed. You needed 17. They add 40. Now they changed the problem, and instead of 40, they use 30. Now they use 30 cubic centimeters of oxygen. However, you're still going to need 17, guys. So 30 does not change. This one is a 30. Doesn't change anything because it's still in excess. So the graph, when you draw it, if this one is P, then that one is also going to be Q, because it does not make any change. So Q is going to be right on top of P. They are going to be exactly the same graph. That I want you to note, because there is no difference. You add less oxygen, however still in excess. It's to add now 30, but nothing changed because it's still more than enough, more than the amount you actually need. Let's go to question 5.6. The reaction is now repeated at the same condition using 40 cubic centimeters of oxygen. Platinum is added in the reaction. Platinum increased the rate of the reaction without undergo a permanent change. Guys, this one, before even reading anymore, is a catalyst. Platinum here was a catalyst. Define the term rate of reaction. Okay, so what is rate of reaction? Is the change in concentration of reactant or products per unit time. Rate is equal to the change in concentration of reactant or product per unit time. This one is the formula for rate and is for the definition. Okay, so that is question 5.6.1. Question 5.6.2. Write down one word or term for the underlined phrase, guys. We answer here. This one is question 2.6.2. It is a catalyst. Catalyst is the substance that increases the rate of the reaction without itself undergo a permanent change. It's not form part of the reaction. On the same set of axes as question 5.5, sketch the graph that will be obtained when platinum is added. Level the graph R. Use okay, and then we're going to the 6.4.4. Let's go 6.6.4. Let's go to 5.6.3, and we are going to do it together with the 5.5. So this one is going to be 5.6.3 as well. So now they add in a catalyst. So what does a catalyst do? It increases the rate of the reaction. Now, nothing else changes, but the rate increases. Same amount of product, same everything. So this is going to be a higher gradient, which means it must be close to the y-axis, guys, but it must end up in the same point as before, because it's producing the same amount of gas. So this graph here is going to be the graph that they want us to call R. It is on top because it is happening faster, the rate of the reaction and faster, but it other word, it produced the same amount of nitrogen dioxide. So that is the graph. It's just closer to the to the y-axis because it's going to be happening faster, so it will end before the other one, but otherwise is exactly the same. So let's go to the very last question of this question paper. And the last question says use the collision theory to explain how platinum increased the rate of the reaction. So what is a catalyst do all the time? A catalyst, the first thing to do is lower the activation energy by providing an alternative path. And therefore, if you have now less activation energy, less energy needed to start the reaction, there will be more particles which have now sufficient kinetic energy, and therefore more effective collisions per unit time. And guys, this is the end of the question and as well the end of the video. I hope it helped you. You're supposed to be doing this one at school now. It is very important for June, for September at the end of the year. So we are done. I hope it helped. Subscribe for the channel if you didn't yet, if you think it helped. I'll post more videos. Next time I'll be posting more questions on rate before we end in this question paper. But I'll see you next time. Mr. G here.